Researchers in NETL's Thermal Analysis Laboratory are investigating chemical looping combustion. As a clean and efficient fossil fuel technology, chemical looping combustion controls CO2 emissions and offers a promising alternative to traditional combustion. The chemical looping process uses oxygen from an oxygen carrier rather than oxygen from air, and produces only water and carbon dioxide during combustion. The water is condensed, leaving the combustion gas stream with a concentrated stream of carbon dioxide that can be readily captured for storage.
It's very similar to what occurs in your body, where you take in air, you react the air inside your body with hydrocarbons, essentially carbon and hydrogen, just like this sample of coal, and you create energy that you use for the things you need to do. So we're trying to replicate that process here in a way that we can use it in a power plant to generate electricity.
The chemical looping combustion process is efficient because it does not require expensive gas separation technologies to produce a concentrated stream of CO2 from flue gas. Current research is focused on finding an effective, economical oxygen carrier, which will supply the oxygen for the reaction process. Oxygen carriers are primarily composed of metal oxides, such as iron oxide and copper oxide. NETL researchers are developing novel formulations of oxygen carriers and taking them through a rigorous evaluation process to find one that is low cost, environmentally benign, reactive, robust, and stable for many cycles. Testing begins with milligram-level quantities of oxygen carriers using thermogravimetric analysis, which monitors weight as a function of time. In order to test the reactivity of the oxygen carrier during thermogravimetric analysis, the sample is heated to the combustion temperature and fuel is introduced. As oxygen is released for the reaction with fuel, the sample's mass changes, and researchers can monitor the rate of the reaction based on how quickly the mass changes. If results are promising, the sample moves on to larger scale testing in gram-level fixed bed and fluidized bed reactors. In order to survive during long-term tests, the oxygen carriers must be durable with high physical stability or high attrition resistance. Researchers test samples with sufficient reactivity for attrition resistance under more rigorous conditions. If results are favorable, the sample is produced in large quantity for testing in NETL's pilot-scale chemical looping reactor. Chemical looping combustion for power production has the advantage of increased efficiency coupled with built-in carbon capture. A critical step toward enabling this technology is to formulate robust, cost-effective oxygen carriers. Novel formulations developed as a part of work conducted in NETL's Thermal Analysis Laboratory have so far resulted in 2 patent applications.